Hello, welcome to Introduction to Limits for Precalculus. This is a three-part series. In part one, we will focus on the table method. First of all, understand the limit notation. We have the example right here. The limit is what we are doing. We say we take the limit, and this is read as the limit of f of x as x approaches a equals the number L. You always have a number on this side or possibly infinity. So remember, limits are y values because you're going to find out what y value f of x will equal as x approaches a in this case. Sometimes we have what we call one-sided limits, where we only approach x from the one side, either the left or the right. So in this case, if there's a plus there on a, that means we're coming from the right. We're going towards a from the right. If we have a minus sign on a right here, that means we're going to be approaching a from the left, going towards a from the left. And then we could also approach positive or negative infinity. The limits are found three ways, and we're going to focus right now on the numeric way, which is we have x and y values in a table, and we analyze what's happening to the y as x goes towards a. Before we start having you make your own tables, we're going to review what we already learned about asymptotes, because remember, asymptotes are lines, imaginary lines that the graph approaches but does not cross, or does not touch or cross. So when we study vertical asymptotes, we would, for example, make a graph of 1 over x minus 3, and it turned out to look like this, and we had a vertical asymptote. Well, if you were to make a table of this one to find the limit and have x values approaching 3, which we'll say is our a is 3 in this case. Your table, of course, won't be left and right, but your values that are less than 3 are going to be at the top of the table, and you see I've put in these values to make them closer and closer to 3, and the values that are greater than 3 are going to be at the bottom of the table. So you have to kind of adjust in your mind, realizing that top and bottom are really left and right. And look at what's happening to the y values. I did this on Desmos, but I'll show you also how to do them on the graphing calculator. As you get closer to a equals 3, your y values are taking off, which we remember means that they're going off as you're getting closer on, on the left. Your y values are taking off to negative infinity. And we just have a few values. You're not going to actually see infinity, but you can see they're getting very high in the negative direction. And as we approach x from the right, which will be these values down here, as we get closer and closer to 3, from the larger to the smaller, it's going to be undefined where the vertical asymptote is, and these are going to get very large positive values. So for limit notation, what we would say is the limit as x approaches 3 from the left of this function equals negative infinity. Now it doesn't actually, you cannot equal negative infinity because it's not a number, it's not a boundary, it's not a limit. But we use this notation because we're interested, are we going to negative or positive infinity? And then we have x, as x approaches 3 from the right, the f of x is approaching positive infinity. And that would be read from a table like this. We will also briefly review horizontal asymptotes, because when you are finding a horizontal asymptote, you are finding a limit. So you will use the exact same 3 cases that you use to find horizontal asymptotes when you're asked to find a limit. Because when you find a horizontal asymptote, you're finding what is, I'll show you over here, what is the limit as x approaches either positive infinity or possibly negative infinity. What's happening to that function as x gets very large? Now, if you're doing this in a table, you're going to have to put in values that get very large in your table. And the good thing about using a table is it doesn't matter what the window is on your graphing calculator. You can put any values in you want. So it's actually a little easier than trying to do it from a graph. Here I put in larger and larger positive values, and you can see that the y values are getting very close to 0. And here I put in larger and larger negative values, and you can see that the lines are the y values are also getting very close to 0. So in this case, where the degree of the denominator is greater than the degree of the numerator, we learned that the horizontal asymptote would be y equals 0, and the limit is 0 as well. They are the same. The horizontal asymptotes will give you the limit. Case 2 for horizontal asymptotes was when the degree of the numerator and denominator are the same, and we learned that the line, the horizontal asymptote line, is y equals the ratio of the leading coefficients. So if you were to do a table again, now I do have the graphs here so you can see how the graph does approach 2, but we can verify that if we're thinking about tables now. We put in larger and larger numbers, and already when you're even at 100, it looks like you're getting very, very close to y equals 2. And same in the negative direction, getting very close to y equals 2. Still positive 2 on both sides when you're going to positive infinity or to negative infinity. So here's the notation. As x approaches infinity, the limit of this fraction is 4 over 2, which is 2, but you could also see the 2 from the table. And the same thing with the negative infinity. The limit is 2. Case 3 is when the degree of the numerator is greater than the degree of the denominator. The numerator dominates with a higher exponent, and in that case you do not have a horizontal asymptote, and in other words, your y values do not approach a number, they approach infinity. So if we were to do a table, we would see as the x values get very large in the positive direction, the y values get very large in the positive direction. So we would say the limit as x approaches positive infinity is positive infinity. And then if we check out the negative values getting larger, then the y values are getting larger in the negative direction. Therefore, that limit is negative infinity. Now it's time for you to try your own tables. I have instructions here for the graphing calculators, the TI-84s and 83s. Whatever utility you have, you need to be sure to know how to use. And if you're going to be in a test situation, you won't be able to use the internet. So make sure that you are capable of getting these on your own graphing utility. On the TI-84, you have options table set and table to find those keys. If you want to choose your own x values and make your own table of x values, then you need to change. This actually stands for independent, automatic, or ask. You need to change the independent variable, which is your x variable, to ask. The depend always stays on auto. It really doesn't matter what you have, where you start your table, or how you increment your table, the delta table. These don't matter if you're going to put in your own x's. So you have that option, which is very similar to what you do on the Desmos convert to table option. You can put in your equation, y equals whatever you have, and then there's a little gear here that lets you edit, and then you will convert to table. Once it gives you options, choose the one that has the table, and then it will give you some x values and you can change them to whatever you desire. Our first example is the limit as x approaches 0 of sine of x squared over x. Now you have really no other way of doing this. This doesn't fit into your asymptotes, and you can't do anything algebraically with this one. So you're really only choice. So you could do a graph and guess what it is as x approaches 0, but we're going to get a little more accurate answer with the table. Now be careful whenever you do trig functions, you must be in radian mode. Make sure you change to radian mode, because all calculus trigonometry is based on radian mode, and the answers will be different in degrees. You'll find that out. See if you can duplicate these tables. Now, I have you could put these values in yourself, I chose to go 0.003 away from 0 and then come from the negative direction and then go in the positive direction. You can do this with a table setup. We're going to use the automatic function this time. We're going to say where to start, and I chose 0.003 to the left of 0, which in this case is negative 0.003, and I decided to go up by increments of 0.001. And then you can see what's happening as you get very close to 0. Remember, your scientific notation on your calculator is not actually -1e -3, but you will be translating that into -1 times 10 to the -3rd, which is a very small number. It doesn't even matter whether it's a -1 or a -9, but if you have an exponent of -3, you have a very small number. So you're getting very close to 0 from either side. 1 times 10 to the -3rd from the right, and -1 times 10 to the -3 from the left. So this will automatically, because I have put in auto here, it will automatically start wherever I start and then add 0.001 to the x values on either side of 0, and then you can observe the y values. So the answer to this problem is the limit as x approaches 0 of sine of x squared over x equals 0, because you are approaching 0 y values from both the left and the right. Here's another example to show you that you will get, if you remember, Desmos gave you an undefined when there was division by 0. The graphing calculator gives you error, so sometimes you don't have that value there, but sometimes you do. Look at this one. This is that same fraction we looked at before for the vertical asymptote, but this time x is approaching 4 instead. So you could do this with your table start equaling 3.997 instead of -0.003. You want something that's a little bit below 4. And you could choose different values as long as you're seeing an obvious answer. And then you're getting closer and closer to 4, and then just on the right side of 4, you're going on the other side. And on both sides of these, you're getting very, very close to y equals 1. So the answer to this one is the limit as x approaches 4 of this fraction, 1 over x minus 3, equals 1. So if you were to draw this graph, you would see that that is right on the solid line of 1 over x minus 3, and that value is there. So it doesn't matter. With limits, you are only finding what y is approaching, what y is getting close to, so it doesn't matter if it's there or not. You're getting close to the value.